we're going to look at some position, velocity, and acceleration graphs for projectiles. So we want to analyze the horizontal and the vertical direction separately for this. Left column for what we know is happening in the horizontal direction, right column for what we know in the vertical direction. If we have this for a horizontal position versus time graph, we would say the object starts at 0 and moves to more positive x positions. In other words, it moves to the right. It does that in a steady way. Constant slope of position time means velocity is constant. Horizontal velocity is some constant positive number. Slope of that velocity time graph is 0, therefore acceleration is 0, which is what is consistent with what we know for projectiles. Projectiles don't have any force acting in the horizontal direction, therefore no net force, therefore no acceleration in the horizontal direction. In the y direction, if we had that for the corresponding y versus t, then that would tell us that the y position starts off at a positive number, ends up close to 0. In other words, the object travels down. But it does that in a changing speed way, curved line. That's a half a parabola there. And that's because the vertical velocity changes. It starts at 0 and gets more and more negative as time goes by. In other words, the force of gravity causes that object to accelerate towards the Earth if it is a projectile. It's not being held up by anything, so it travels faster and faster towards the Earth. Vertical velocity starts at 0. That would be consistent with it, let's say, rolling off of a table or a bullet being launched horizontally. And as time goes by, it moves faster and faster in the vertical direction. Nice, constant positive slope for velocity time, so constant negative acceleration. We know what that number is, negative 10 or negative 9.8 meters per second squared if we're on Earth. Here's another situation. What if I have that green one for a position versus time, horizontal position versus time? Object still moving to the right, but not as fast because the slope is not as steep. Still moving to the right, just not quite as quickly. Still has 0 acceleration because its horizontal velocity does not change. If our y versus t graph for this looks like that, then we would see that that y velocity starts off, or the y position starts off near the ground, it ends up near the ground, but in between it moves up high. That means that that object must have been launched at some kind of an angle that make it travel upward and then back down. The velocity graph for that starts off positive because the object is moving upward to start off with, ends up negative because the object is traveling downward to end with. Meanwhile, it's also moving horizontally, and it passes through 0. The meaning of that place where that Vy passes through 0 is the turnaround point. It would be the highest point where the vertical velocity is 0 at the top of the path, at the highest, at the peak. And notice that the green and pink lines for Vy versus t have the same slope because they are both changing because of the acceleration due to gravity. So, recapping, vertical velocities change no matter what, whether I have it launched horizontally or launched at an angle. The vertical velocities change because of the influence of gravity. The horizontal velocities stay constant no matter what, whether it's launched horizontally or launched at an angle, because there's no force in the horizontal direction that can cause it to change, so it doesn't. Always a good idea to be able to reproduce those graphs, to start with the axes and seeing if you can sort out what would be happening with those graphs. Hope this is helpful.